Welcome to this Trimble Business Center video tutorial. In this video we will work with the TBC tutorial data processing DGI aerial survey data, and the main topic of this video today is orthophoto generation and production. I used a project from one of the previous videos called Tbc Apm full course ground control point measurement, and we will now use this orientation that comes out of here for our orthophoto production. Before we look at the user interface in the deliverables, we want to explain here the workflow in general, and this is best done again through the workflow bulletin, which you can always access when you go to TBC to support. You go to the release notes, then your browser of your choice opens up. You will come here to this Trimble Business Center release notes, bulletins and updates page. I will stay here in English, and then you will find here aerial photogrammetry for surveyors, concept and workflow in TBC, and then you can click here view, and then it opens up your PDF. And when we take a look at this PDF, then we will find a section called Ortho Mosaics. So let's just go through it so that we understand the different orthophoto products that you can generate, which is great. So you can have a variety of different outputs depending on your current task. First of all, the ortho mosaic is strongly correlated with your elevation model. That means with your point cloud. So if you are not sure about point clouds, then please look at the previous video, point cloud generation or deliverables point clouds, where we show all the different point cloud outputs that are possible in TBC. To simplify the whole process, we will here try to simplify it to two main products. One we will call the classic ortho mosaic, and the classic ortho mosaic uses a terrain model or point cloud that is representing the ground, here shown by these green squares, and therefore we call it a digital terrain model, a DTM. And no surprise, when you select in TBC the elevation type digital terrain model, then this is the point cloud that we try automatically to extract. In the previous video we also have shown here, for example, the difference between the digital surface model and digital terrain model, where we see that the DTM always tries to stay on the ground. Don't make the mistake, the DTM does not need necessarily the same raster distance as your final classic ortho mosaic. So we can use the original image with the highest resolution, take a pixel from this, then project this one pixel somewhere on this terrain model, and you see it does not need to hit the corner of our point cloud. It can be somewhere on this green surface. We interpolate from the surrounding points its height, and then we can now auto rectify it here depending on our scaling on our orthophoto, on its position. And therefore you don't need to have the same resolution in the point cloud as in the ortho mosaic in the end. Of course, the more undulation and the more complex terrain you have, this more coarser terrain model will not represent every object or every edge or every small slope change in your terrain model itself, and therefore denser point clouds tend to give us more accuracy and more detail possibilities later to truly auto rectify a pixel from our image to the correct orthophoto position. But the interpolation method is a very common approach. That means as long as our DTM does not include extreme height errors, this interpolation method is enough to generate a correct orthophoto position. So that means the misplacement of our orthophoto pixel is not larger than half a pixel, and then it will be correctly placed in our orthomosaic, and therefore this is how we call it classic orthomosaicing. Of course, if you look at this tree here, it's shown here by a tree, but we could also use here a building, but trees, it's more easy to understand. If I have now on my image this crown of my tree where this red line enters the tree, then we don't have a terrain model representing the top of the tree. Our terrain model, the green one, is at the bottom of the tree, at the ground. And therefore, this red line is not auto-rectified here and placed down here to the Stumpf from the tree. But in this case, the crown here will be extended, and that means in the orthophoto, then my object lays down in this case. So it's not true auto-rectified, but in this case here, it's leaning into our orthophotos. Depending how far outside in my original image my object exists, the leaning can be larger. If my objects are closer to the center, then the leaning is smaller. And of course, if it would be exactly at the projection center, then there would be no leaning. It would look like a correct true auto-rectified object. So therefore, this is something to be also taken into consideration. The good thing for us is that we have a lot of overlap in drone images, and therefore we can avoid to use from all the images the outer parts, because when we take a second image, then it overlaps by 80% the first image, and the third image still is covering 60% of our first image. That means we can just take center parts of our images to auto-rectify, which means the leaning effect will be minimized. In TBC, when you are calculating a DTM, then we will generate from each aerial image, so here in our example we have 8 aerial images will generate 8 orthophotos. These 8 orthophotos will then automatically run a seamline generation, so we try to find a position where we can blend from one ortho to the next without that the user can see it. And then we get one single mosaic, and these are the seam lines that are not written, of course, into the mosaic, but are used only to blend these 8 orthophotos into one ortho mosaic. The same procedure also happens when you generate a digital surface model. So from 8 aerial images, we will generate 8 orthophotos, but this time our point cloud is not staying on the ground, but tries, in this case here, always to be on top of objects, here just shown by this building. That means our point cloud has not points on the bottom of our building, but on top of the roof. And same would be also with the trees. I did not show it here in this graphic, but the points are not here at the bottom, but they are here. Normally these green dots, they should be all plastered here on top of the tree, and also here on top of the tree, so that we generate then somehow like a true orthophoto for our for each single image. That means if I go back here to this part, we have then 8 aerial images. For each aerial image we generate from the DSM an orthophoto. This time here the orthophotos try to be more true orthophoto-like. And then with these true orthophotos we still merge them together with seam lines and generate them here into a mosaic. So DSM and DTM workflow in TBC are using this approach. The disadvantage of true orthophotos using the DSM approach with here this way is that you need to put a lot of effort into buildings, because we want to have buildings nice and sharp in true orthophotos typically. and therefore just purely running it on the point cloud itself is not sufficient. So what is happening here, we have a third method, which is then called the DSM high quality. And in the DSM high quality, we are here, there's a mesh, or somehow a DSM meshing happening that emphasizes here these rooftops, these edges of the roofs, and also tries to minimize amounts of point along the facades so that they are straightly dropping down and then creating here this true auto-rectified building where the edges of the building are sharp and nice, displayed in our final true Orthophoto product. So looking at the workflow, that means we have our 8 aerial images, but we are not generating 8 orthophotos, but we are here running, in this case here, this point cloud, where we are running in the background some meshing and some DSM generation, some edge enhancement, some facade corrections, and therefore then afterwards from these 8 images and this point cloud, which is in this case here using also textured meshes, directly the auto mosaic, which is in this case the true auto mosaic process, we call it, and accessible when you select in TBC the DSM HQ workflow. So the video wants to go a little bit also deeper into this whole part. So here now a little bit more advanced. As I mentioned, we are not using in the DTM and DSM the whole image for the auto rectification, but what we are doing here is avoiding the image content in the furthest parts of the drone image, because there are the largest distortions and also the most leaning of objects happens in this part. And therefore, when we have here an 80% overlap, then if this gray image here is my image, then we are only using this green area part for the orthophoto rectification. Because when I use from this first image the green part, and then from the second image the green part, and from the third one, then these ortho areas are still overlapping. I can still detect this seam line between the ortho photos. This is not anymore aerial image, this is orthophoto area, and these overlapping parts of the orthophotos still allow me to make a seamless mosaic generation, and therefore we can only focus on the center part of this part. It has also an advantage that your height model can be lesser accurate and still not create misplacement of our pixels, because a height error closer to the nadir position will cause a lesser positional error of my pixel. So this finishes the introduction to orthophoto generation. In the next video, we will take a look at TBC and the functions, how to create orthophotos, and some examples showing the results. So thank you for watching and have a nice day. Goodbye.